welcome back to A Gal's Guide to the Ocean.
Yeah.
Today we're starting SLO 4.
Yeah.
And that is what topic, Catherine?
Ocean life.
And it's your favorite host,
Catherine, yep.
and JD. Woo!
Whoa. To first start off this podcast, a key thing to know about ocean life is primary production. What primary production is the creation of new organic matter from inorganic substrates. The organic matter is special because it's the base of the food web for almost all marine consumers. Marine plants and algae, how do I say this, JD? Algae. They're the ones who are responsible for oceanic primary production. When these producers create the organic material, this is called the gross primary production, but the producers also consume a portion of the organic matter through respiration. The amount that is left to support the consumers is called net production. The gross production that I discussed just now is divided into two groups, which is new and regenerated production. The way new production is supported is by the outside nutrients of the local ecosystem. And regenerated production is the result of the recycling nutrients within the ecosystem.
Excellent point, Catherine.
Yeah, thanks.
Yeah, of course. So now we're going to be discussing the major organisms involved in oceanic primary productivity. So some of those responsible organisms for the primary production include a variety of marine plants as well as algae. And the greatest amount of photosynthesis in our ocean is from microscopic algae. Algae.
It's okay, been there, done that.
Exactly. And so another name for this is phytoplankton. And this just kind of reminds me of plankton from SpongeBob. Anyways, off topic. What's that? Well, plankton means organisms that drift with currents, and so phytoplankton are kind of like free-floating algae that go through photosynthesis in our ocean. Also, fun fact, zooplankton are drifting animals, so that would be like jellyfish. It would not be SpongeBob because SpongeBob is a sponge, Catherine. Phytoplankton are microscopic in size versus like the marine plants and macro algae, but they're 95% of all our marine primary phytoplankton, or marine primary productivity. And so most of the production by phytoplankton is coming from three groups, and those three groups are diatoms, dinoflagellates, and excuse me if I pronounce this wrong, and coccolithophores. So diatoms are single-celled algae. They're about 1 millimeter in diameter, and they can be a lot of shapes. And also 55% of those absorb sun energy, incorporated into carbohydrate formation, and they're also abundant in the coastal and cold. They are also in nutrient-rich waters. Oh, and they have mineralized shells. Now, for the dinoflagellates, this is another type. They're smaller, about 0.04 millimeters in size or range or whatever. And they have no mineralized shell, unlike the diatoms. And these are covered in cellulose, and so that makes it decompose quicker in seawater. And some of these dinoflagellates ingest prey, which is kind of different. And so for coccolithophores, these are the smallest out of the three. They're about 5 to 100 micrometers wide. Their shell is made up of a lot of interlocking arcular plates made up of calcium carbonate that they together they all make a sphere, and you can find these in warm and open ocean waters. And of course there's other groups like bacterias that we won't get too much into detail, so that you just have a general idea of what this really is.
Okay, so in ocean life, light availability and how it changes with the depth is actually important. So some of you may know that light is vital for photosynthesis. So when the depth increases, photosynthesis cannot occur. However, the euphotic zone is where sufficient light for photosynthesis is penetrated. Also, when the rate of photosynthesis declines, a point is reached where the photosynthesis rate equals the respiration rate, and this is known as compensation depth because the increase in depth caused the equality. This type of depth marks the lower level of the photic zone and represents the depth where net primary production ends.
So, Catherine talked about the depth and light. So now I'm going to describe the seasonal patterns in productivity in the polar, tropical, and temperate regions, and the factors responsible for those patterns. So those responsible for regional and seasonal changes in primary production are due to a combo of the availability of light and nutrients provided by the water mixing above the thermocline. Now, you're probably like, JD, what the heck is a thermocline? And that's a valid question because I had it too. It is a transitional layer between warmer mixed water at the surface and cooler water below. And so in the tropical regions, sunlight is plentiful throughout the year. So the light is not like a limiting factor. And the surface water is always warm because there's always light. And there's always a thermocline. Not much production, however. So the nutrients are limited, and that does result in poor nutrients. And so the water is clear. If you can think about tropical regions, this is like wherever the water looks super pretty. So wherever you'd go on vacation to, like Hawaii. And that's the only place that I would personally.
Bora.
Oh, Bora Bora too.
Right, Bora Bora. I want to go.
Yeah, we definitely have to put that on a bucket list. And at the poles, it's cold, and it's at all depths that it's cold. There's not much of a thermocline, and there's barely any stratification. It's not nutrient limited, however, but during the winter there's no light, and so winter brings abundance of nutrients, and during the spring and summer, phytoplankton begin to bloom, and by late summer the nutrients deplete and bloom declines.
How does phytoplankton bloom?
That's a great question, Catherine. So basically, phytoplankton bloom based off of the nutrients in the water.
Okay.
Yeah. So if there's a lot of nutrients, they're gonna bloom, and it also has to do with a lot with the temperature, like in the chapters that we covered earlier.
Yeah. So like, does it grow like from like the deep depth, like down there, or?
I don't think there's any specific level. I think as long as it's like relevant and parallel to the thermocline, I think.
Okay, I was just asking because there's more nutrients at the bottom. But, okay.
That's true.
Thanks for the clarification.
But the nutrients do flow around, so
Okay, makes sense.
So where was I?
Sorry.
You're fine. And so by late summer, the nutrients deplete and bloom declines. In the fall, light declines, and this prevents the production in the wintertime. As for the temperate regions, there's more seasonal variation in the depth and intensity of the thermocline. So in the summer the thermocline is shallow and stronger, while in the winter it's deeper and weaker because winter has little production because of the light limitations, of course.
Okay, so JD talked a little about nutrients, and we also talked about it in the past SLO, but I'll be talking about it more. So nutrients are very important because it's required by all of the marine primary producers. These nutrients are not distributed evenly throughout the water column. At the surface, the nutrients are quickly used by the phytoplankton, which results in the water being nutrient poor. The phytoplankton can be consumed or dies. So they get recycled into particles of organic matter that sink into deeper water. The decomposition of the materials in the deep water release the nutrients back into the water column. When they're at deeper depth, they're not getting utilized, so there's a larger quantity of the materials.
So now to close it off, I'll be discussing the nutrients needed for primary production. Those required by all of the marine primary producers and the major ones required by phytoplankton are nitrogen, phosphorus, but in the forms, they're different forms of those. And so they're nitrate, nitrite, ammonium, and phosphate. And so I'll try to put a picture up there to show you what the chemical, like, short version of it is. And some of those also need silica for shell formations. So these are all kind of occurring in small amounts in our seawaters. And as we close, please make sure to hit the subscribe button.
Help a small YouTube channel out. We're in need.
And thank you for joining us. Until the next episode.
Bye.